we're going to learn about radians and how to convert from radians to degrees. Radian is a measurement for angles. So it's kind of like, how you say 360 degrees, you're representing an angle. Radians is basically another unit for kind of measuring angles. Now remember back to the circumference of a circle. That's equal to 2 pi times the radius of a circle, right? And it's used to find this. You can think about this as like the outer ring of this circle, right? Now radians just means radius length. So because a full circle has a circumference of 2 pi times the radius, then there are 2 pi radians in a complete circle. All right, so radians is just like radius lengths. So in this circle right over here, right? Let's say if the radius of my circle is 1, right? Now, if I took 2 pi radius lengths, so 2 times pi, we know pi is about 3.14. So 2 times 3.14 is 6.28, right? And basically, all the circumference formula is saying is that if we took 6.28 of the radius length, so let's say if I have a radius, all right, 6.28, right? So I stack 6 radiuses or 6 radii on top of each other, and I add extra 0.28 at the end. And then what I do is I can wrap it around a circle, right? So let's say I take this line and I wrap it around a circle, and it turns out that it covers the full circle. So yeah, that's basically like the circumference formula, right? What this 2 pi basically means is that if you take 2 pi or 6.28 of any radius length and you go ahead and wrap it around your circle, it's going to cover the whole circle. It's going to cover the whole circle. Now, we know that in a circle, right? A circle has 360 degrees. So all of this right over here is 360 degrees. But from what we learned, we also know that a full circle is 2 pi radians, right? It takes 2 pi radius lengths or 2 pi radians to wrap around the circle, right? So 2 pi and 360 degrees are equal to each other, right? 360 degrees, you go around a circle 1 time. 2 pi radians, you also go around the circle 1 time, right? It wraps fully around the circle. Let's say if you have 180 degrees, how can you convert this into radians? Well, kind of a simple way to do it is we know that for every 360 degrees there's going to be 2 pi radians, right? So that means that once we simplify everything, so 180 degrees times all of this, the degrees are going to cancel out, right? This unit is going to cancel out because it's in the top and the bottom, right? So then we're just going to be left with radians as our unit, which is what we want. So 180 times 2 is going to be 360, right? So we're going to have 360 pi radians. 360 divided by 360 is just going to be pi, right? So our answer is going to be pi radians. And that makes sense because we know a full trip around our circle is going to be 360 degrees or 2 pi, right? Which means half of the circle, so that means that, just using a different color, which means that half of the circle, which represents 180 degrees, right? Because 180 is half of 360. Well, this is also going to be equal to pi, which is half of 2 pi, right? Half of this angle is the same thing as just half of this radians, right? So 45 degrees. And we want to convert this into radians. Well, all we have to do is, once again, you can say that for every 360 degrees, there's going to be 2 pi radians. And you can actually simplify the inside. You can say that for every pi radians, in this case, there's going to be 180 degrees, right? Because that's what we saw from before, right? We saw that for every half of a circle, which represents 180 degrees, well, that's also going to be equal to pi radians, right? So for every pi radians, there's 180 degrees. And simplifying this, we're going to get 0.25 pi But usually for radians, we like to write it as fractions. So we just write pi over 4 as our answer. Pi over 4 as our answer. Now, we know that this has to be the correct answer, pi over 4, because, well, 360 times 1/8 gives me 45 degrees. All this is saying is that 45 degrees, this is a badly drawn circle, but all this is saying is that 45 degrees is 1/8 of the whole circle, right? 45 degrees is 1/8 of the whole circle. Now, if I multiply 2 pi times 1/8, I'm going to get pi over 4. Now, I know that 360 degrees and 2 pi are equal to each other, meaning that the resulting answers have to be equal to each other, right? So 45 degrees is equal to pi over 4. So this is also going to be equal to pi over 4. Now, here's like a couple of extra things about like radians. We know the whole circle is equal to 2 pi, right? And we said that if the whole circle is 2 pi, well, half the circle has to be pi, right? Has to be half of 2 pi. Well, if we have half of pi, so that means if we know that pi is this part right over here, right? This length. If I have half of it, well, that's going to be pi over 2, right? Half of what I had before. And if I took half of pi over 2, well, I get pi over 4, right? So there's like, these are just like a couple of things to know. 2 pi is 360 degrees. Half of 360, that's 180, right? We said how we represented a semicircle, right? The semicircle part. Half of 180, we know that's 90 degrees. So that means pi over 2 represents this part, right? Because it's half of 180. That means that pi over 4 represents 45 degrees because that's half of 90 degrees, right? That's pi over 4 is half of pi over 2. So that has to represent 45 degrees. Now, let's say if we start off with saying, okay, I have 3 pi over 2 radians, okay? Let's say I have 3 pi over 2 radians, and I want to convert this into degrees. All you have to do is you literally just have to do the opposite of what we did before. Before, we said that, before we kind of put the degrees on the bottom and then the radians on the top. We just reverse it. So we know that in this case, there's pi radians. There's pi radians in 180 degrees, right? That is kind of our conversion kind of factor, right? Before we said how pi is equal to 180 degrees. So in this case, if I want to get to degrees, well, I know that there has to be a radians on top and a radians on the bottom so that I can actually cancel out the units. So I can actually cancel out the units. So now I'm left with degrees, which is the unit I want. So doing this calculation, I get that. So now that this is going to be equal to 270 degrees. You can also just put this in your calculator, right? 3 pi over 2 times 180 over pi. The pi at the top and the bottom will cancel out. The 180 and this 2 cancels out to be a 90. So then 3 times 90 is just 270. We can do another problem. Let's say if I have, 5 pi over 6. And then I multiply this. Well, hold on. Let's say I have 5 pi over 6 radians. And I want to get to degrees. How do I do this? Well, we know that there's going to be pi radians. There's going to be pi radians in 180 degrees. So make sure that your units always cancel out when you're doing these types of problems. So if you're converting from degrees to radians, make sure that there's a degrees in the top and there's a degrees in the bottom, right? So that they cancel out. In this case, if we're converting from radians to degrees, well, make sure that there's a radians on the top and there's a radians on the bottom. So this is 5 pi over 6 radians, and then there's a pi radians in the denominator, right? So there's something in the numerator and there's something in the denominator. So that means that the radians will cancel out. and you're just going to be left with degrees. So this is going to be the pi's are going to cancel out. 180 divided by 6 is 30. 5 times 30 is just going to be 150. And that's our answer.